Hi, everyone. My name is Mohammad Ashik Salim, and I'm here to present our work in AdaBoost-Powered IoT system for real-time pediatric sleep pattern recognition. So this research was conducted together with Dinesh, Gaurishwari, Saranya Durai, Pramod, and Vidya. So let's get into the presentation. So the need for automated pediatric sleep stage recognition is increasing because of more children are experiencing sleep problems. Our research explores, the option of using deep learning approaches, specifically like convolution neural network and pulse oximeter data to automatically categorize sleep phases in children at risk for obstructive sleep apnea. So traditionally, the diagnosis methods used are, such as like uh, polysomnography are more expensive and more cumbersome for use. And the lack of sufficient, diagnostic abilities was discovered using the data mining methods, which prompted the creation of a fresh survey and machine learning model to improve the accuracy. With an emphasis like on a nighttime polysomnography, the research seeks to understand how applicable sophisticated algorithms are for automated sleep stage detection in pediatric uh, patients. So the paper uses topological data analysis like TDA on brain connectivity networks from EEG signals to identify statistical difference between pediatric patients with or without obstructive sleep apnea. So the study also investigates on how sleep apnea affects, slow oscillation in EEG and cognitive abilities, and explores, cardiopulmonary coupling as a biomarker for OSA severity. And our goal is to apply advanced algorithms for more accessible and accurate pediatric sleep stage detection, which could be more non-invasive and then very easy on the pediatric patients who are more prone or scared to have many sensors connected on them. So some of the literature review discussing about the around the sleep apnea was like to diagnose apnea hyponia syndrome. This is like known as like shortly known as SAHS. In children, the nocturnal oximeter with bispectral analysis of blood oxygen saturation was used to reduce data duplication. It investigates how bispectral analysis may supplement, SAHS related data sets. So the previous studies have used an nocturnal oximeter bispectral analysis to diagnose these apnea hyponia syndrome in children. Manual sleep staging in tedious but necessary. And while many deep neural network models exist, a few uses EEG data from children. A new hybrid neural network method has been proposed for automatic sleep staging using pediatric EEGs. And other research includes using 3D face imaging and geometric analysis for supervised and unsupervised diagnosis, and using oximeter and RIP bands for OSA severity assessments. And nocturnal polysomnography is a golden standard for diagnosis, but it is very costly and it is very difficult to have access to as well. So recent work also introduced responsible, explainable AI to ensure ethical and transparent medical diagnostics and automated facial analysis for identifying, pediatric OSA. So the proposed system we have is using AdaBoost-powered IoT system to track pediatric sleep apnea patterns, like pediatric sleep patterns in real time. The system combines machine learning with IoT technology to track and analyze sleep patterns in children. So basically, the system uses wearable sensors such as heart rate monitor, accelerometer, placed in a comfortable wearable as a wearables to collect data without disturbing the children. And the data is transmitted wirelessly to a cloud server where it can be processed securely. The AdaBoost algorithm, which combines several weak classifiers, forms the core of our system analytics. The algorithm analyzes incoming sensor data in real time and identifies sleep stages and abnormalities. And if the system detects a possible problem, it sends an alert uh, through a user-friendly dashboard or a mobile app. The system is designed to learn and improve over time with regular performance evaluations. So some of the sensors we are planning to employ as part of the systems are accelerometer, heart rate monitoring, temperature sensor, and then SP oxygen sensors too, like the blood oxygen level sensors. So these the essential. So the essentials of these wearable devices are, the accelerometer would be used to monitor the body movement during sleep stages and disruption. Heart rate monitor becomes more of to measure the heart rate and variability in the heart rate to help identify different, sleep phases and detect if any problem, is there. And the temperature sensor would basically check the health issues and ensure there is a suitable, sleep environment. And the blood oxygen measurement will give us the understanding of blood oxygen saturation, which is important for diagnosing sleep apnea. So result and discussions. Basically, the AdaBoost-powered system is reliable and accurately tracks pediatric sleep patterns. And then the algorithm uses an ensemble learning accurately and categorizes different sleep phases and detects any irregularities by combining multiple weak, classifier models. And the real-time processing allows immediate detection of abnormal patterns, rather than delayed one. And combining the data from multiple sensors gives us a complete view of the children's sleep health. And the system design allows, to improve over time by focusing on misclassified cases like the false positives and refining them, to become more accurate. And in the cases of, healthcare analytics or intelligence, false positive is heavily discredited. So we focus on improving the model to be more accurate when a problem is detected. So the model is trained and validated on data set with features like movement intensity, heart rate, uh, basically heart rate measurements, temperature, and blood oxygen level. And the feature important analysis showed that that the movement intensity is the most important factor in recognizing the sleep patterns. The system achieved approximately 92% training accuracy and an 88% validation accuracy during the training sessions. And the parents and healthcare practitioner found the system easy to use and valued real-time feedback for timely intervention. So if the system happened to exist, and then this would definitely be beneficial for parents in understanding a child's health, and then for also the healthcare practitioner, this could come handy in identifying issues early on with less invasive methods. So the conclusion here is our AdaBoost-powered system offers a reliable and accurate solution for real-time pediatric sleep pattern recognition, and the algorithm continues to improve and generalizes well to new data set as shown it has high accuracy score. And the movement intensity was identified as one of the most important feature in identifying sleep patterns, and then it could guide future improvements. The system's adaptive boosting method ensures that the weak classifiers are strengthened over time, and the overall system demonstrates a strong potential for accurate pediatric sleep pattern identification and can be further optimized or and by future works. So that's the conclusion of our work. So yeah, and then we also listed the number of references we leveraged from others' work. And if there is any other questions you have about the system, feel free to ask.